This video covers the greatest common divisor and the least common multiple. The greatest common divisor, or GCD for short, of a group of numbers is the largest number that divides all numbers in the set. A set of numbers is called relatively prime if their GCD is 1. There are many ways to find the GCD. I'll be showing you two. The first one I'll talk about is prime factorization. For prime factorization, you'll prime factor each number in the set and then find the product of the common factors. You want to make sure you use the highest power common to all numbers when finding the product. So let's look at a few examples. Let's start with 30 and 42. I can divide 30 by 2 and get 15, and then divide 15 by 3 to get 5. So my factors are 2, 3, and 5. Remember, with prime factorization, only divide by prime numbers. So the same thing for 42. I divide by 2, it gives me 21. I divide by 3, and it gives me 7. So we want to look for what numbers are common in the factoring of both 30 and 42. So you can see here that they both have a 2, they both have a 3. So I want to multiply the 2 and the 3 to get my GCD, which is 6. This says 6 is the biggest number that divides 30 and also divides 42. Let's try it again. This time I'll use the numbers 36 and 132. So I again want to prime factor these numbers. So the 36, I'll start with 2 again. 2 into 36 gives me 18. I can divide 18 by 2 to get 9. 3 goes into 9 3 times. With 132, I'll also start with 2. I get 66. Dividing by 2, it gives me 33. Dividing by 3, it gives me 11. Looking at the common factors, I see they each have 2 twice, and they have 3 once. So I want to use the 2 2 times. So I don't just say, well, there's a 2 in each. I have to say there's 2 2's in each. So it's important that you always use the highest power possible. I also use the 3. So 2 times 2 times 3 is 12. So 12 goes into 36, 12 goes into 132. Notice when I find the GCD, it's smaller than any of the numbers. It could be as big as one of the numbers, but it'll never be bigger than both. All right, so I want you to try one. Find the GCD of 240 and 750, and then check your answer on the next slide. So here's what I got. 240 broke down to 2 times 2 times 2 times 2 times 3 times 5. 750 broke down to 2 times 3 times 5 times 5 times 5. It's really important as you watch these videos that you're taking notes and you're trying these on your own so that when you go to do the homework, you'll be able to do it without any problem. Let's look at what do they have in common. Well, they each have a 2, they each have a 3, they each have a 5. I'm going to multiply those three numbers together, 2 times 3 times 5, and I get 30. So let's try it again. I want you to try it again. Find the GCD of 98 and 117 by using prime factorization. Pause it and then come back and check. All right, so here's what I got. 98 because 2 times 7 times 7. 117, I divided by 3, it gave me 39. I divided by 3, and it gave me 13. All right, so if you felt a little stumped on this one, remember we had that earlier definition that said if they don't have anything in common, their GCD is 1. So here I see I only have 2, 7, and 7 on the left. I have 3, 3, and 13 on the right. So there's always an answer. There's never the answer that GCD is none or GCD is 0. There is this idea that when they have nothing else in common, 1 goes into everything. So our GCD here is 1. Okay. So let's look at the second method, which I do think is my preferred method because it's a little bit quicker. It's called repeated division. So it's going to look similar to prime factorization, but it has a couple of differences. Number one, you don't have to use primes. It doesn't say repeated prime factorization, it just says repeated division. So I can divide by any number that's common to all of the numbers in the set, and I'm going to do all the numbers at once. So we're going to divide by something they have in common. We'll get the quotients, and then we'll look at them, and if there's more numbers we can divide by, we will. If we can't, if we look at the two numbers and they're relatively prime, we can stop. And we will get to that point at every time. We'll always go down until we're relatively prime, and then we're done. All the numbers we divided by, we'll find the product of that, and it'll be the GCD. That may not sound like much right now, but let's look at an example, and you'll see it's really quite easy. Okay, So let's try 450 and 1,000. So right off the bat, I'm going to jump to divide by 10. So I divide by 10, gives me 45. Then I divide 1,000 by 10, it gives me 100. 45 and 100, I know they're both divisible by 5, so that gives me 9 and 20. So 9 and 20, they're not prime numbers, but when I compare them to each other, they have nothing in common. So that's what we call relatively prime, when they have nothing in common. So I stop right there. The 10 and the 5 are the numbers I divided by. I multiply them together. 10 times 5, and that's 50. So I kind of look at it as the outside numbers. What's on the left, that's what I'm multiplying to get the GCD. But we should definitely try this a few more times. So let's try it again with 114 and 600. All right, I jump to, let's just divide by 6. I know they're both even, 114 and 600. I also know that when you sum up the digits for each of those numbers, you get 6 for both of them, which says they're also divisible by 3. So if a number is divisible by 2 and 3, I know it's divisible by 6. I can just jump right to that divisor. So 114 divided by 6 is 19. 600 divided by 6 is 100. 19 and 100, we're done. They have nothing in common, so just the 6 I divided by is the GCD. All right, so let's try it one more time. I have 1,250 and I have 4,500. All right, do you see those zeros on the end? And again, it says, let's just jump right into divide by 10. Gives me 125 and 450. So I know those are both divisible by 5, so I'm dividing by 5, I get 25 and 90. So I can divide by 5 again. And it gives me 5 and 18. Okay, now I'm done. 5 and 18 have nothing in common. So I'm going to take these outside numbers that I divided by, 10, 5, and 5, I multiply them together, and I get 250. You could have been more intuitive than me and looked at the beginning and said 50 goes into 1250 and 50 goes into 4500 and started with 50 instead of my 10 and my 5. That's absolutely fine. There's more than one way to do the repeated division. Or if you just started by 5 and then later by 2, you'll always get the same answer. It's just we're doing both numbers together, which makes it a little quicker. All right. So let's try the second thing in this video, which is called the least common multiple. So we shortcut this one to LCM. So the LCM of a group of numbers is the smallest number that is a multiple of all numbers in the set. Again, I'm going to do both of the same types of methods that I had before. I'll do prime factorization and I'll do repeated division. So for prime factorization this time, we will prime factor just like we did for the GCD, but the LCM will be the product of all factors to the highest exponent that they appear in either of the numbers in the set. Repeated division, we will also do like we did before, where we'll divide until the quotients are relatively prime. But this time, the LCM is the product of the divisors and the relatively prime quotient. So you're going to go all the way around when you're done. Repeated division only works if you have 2 numbers, not more than 2, but I really stick to 2 numbers for us anyway. All right. So let's start by taking 54 and 24 and using prime factorization. So 54 prime factored, I divided by 2, it gave me 27. I divided by 3, it gave me 9, which is 3 times 3. For 24, I divided by 2, it gave me 12. I divide that by 2 again, it gives me 6, and 6 is 2 times 3. So when I look here, I'm looking at how many times does 2 appear in either number. So it's 2 to the first for 54, but it's 2 cubed for 24, so I put in 2 cubed. And then 3 appears 3 times, and appears once, so I'm going to put in 3 cubed. So I don't have to put 4 2's because I see 4 2's on the page. I just go the highest power for either number. So 3 gives me 3, and 3 gives me 3. 2 cubed times 3 cubed is 216. So my least common multiple, this 216, is the smallest number that I can divide by 54 and also divide by 24. Notice these kind of feel backwards. The greatest common divisor is always smaller than the numbers. The least common multiple is always bigger than the numbers. So it feels a little different to say great and get a smaller number and least and get a bigger number. So you have to wrap your head around that because eventually we do get to word problems. Right. Let's take those two same numbers, but this time do repeated division. So I have 54 and 24, and I just decided to start with 2, give me 27 and 12, which I know I can divide by 3, which is 9 and 4. Right. When I get to 9 and 4, I have to stop because there's not a number that divides into both 9 and 4 other than 1. So now that I'm done, I take all the numbers on the outside, 2, 3, 9, and 4, and I multiply them together, and I also get 216. Of course, I should get the same answer independent of what method I use. I do try to tell people that look how this sort of looks like a really messy L, and we're doing least common multiple. If that helps you remember what to do, that you go just straight down for GCM and all the way around for LCD, that's good, and you kind of, even if it's a silly little reminder, is really helpful. All right, so let's try it some more. So I'm going to do prime factorization to start. So I have 300, divide by 2, I get 150. I divide by 2, and I get 75. I divide that by 3, it gives me 25, which is 5 times 5. Same thing for 280. I divide by 2, it gives me 140. By 2, it gives me 70. So the 70 divided by 2 is 35. I divide by 5, it gives me 7. Okay, again, I go back and I look. I have 2 2's on the left. I have 1, 2, 3 on the right. So I'm going to use 2 cubes. I have 1 3. I have no 3's, so I include this 3. I have 5 squared. I have 5, so I'm going to use the higher, 5 squared. This has a 7. I put that in as well. So all of the factors have to appear to the highest power that they are used. Multiplying all those numbers together gave me 4,200. Okay, so let's try 300 and 280 using repeated division. Right off the bat, it ends in 0, so I'm going to divide by 10. It gives me 30 and 28. I'm going to divide by 2. It gives me 15 and 14. I can't go any farther, so I'm going to take those numbers. 10 times 2 times 15 times 14, multiply them together, it gives me 4,200. I like this method. It just seems shorter. I don't have to keep doing all the division. It's just a one-time thing to do. So if you, on the test, you're only having to do one method, this is my go-to. All right, so I want you to try, find the least common multiple of 40 and 81, and I want you to use prime factorization. All right, so here's the prime factorization. For 40, 2 goes in to give me 20, 2 goes in to give me 10, which is 2 times 5. For 81, 3 goes in to give me 27, 3 goes in to give me 9, which is 3 times 3. So on the left, I have 2 cubed, so I write it down. On the right, I have 3 to the 4th, so I put that in, and I have a 5, so I have 3,240. Now I want you to try repeated division, but use the numbers 1,400 and 4,900. So let's see how you did. This time, 2 zeros in each number. I decided I would start with 100 as my divisor. You may have started with 10. That's absolutely fine. So 100 goes in to give me 14. 100 goes into 2,800 to give me 28. I divided by 7. So 7 goes into 14 2 times. 7 goes into 28 4 times. So now I have 2 and 4. Well, 2 goes into 2 1 time. 2 goes into 4 twice. So all of these numbers together, 107, 2, 1, and 2, gives me 2,800. This time, a little different. This is the first time we have the LCM where our result is one of the numbers. So we say the number is bigger, but it could be as big as the biggest number in our set.